Sharon, really, really wonderful to have you here. Super excited about the conversation we're going to have today.
Yeah.
You're super accomplished. I've been, just reading through your background and getting to know you a little bit. Done so much from your educational background to, being a adjunct faculty member at Stanford, to all the work you're doing on Coursera, and now, a founder of Lamini and sort of at the leading edge of what's going on with Gen AI. So what I'd love to kick things off, just introduce yourself, tell us a little bit about yourself and your company before we get into the rest of this.
Yeah, first, very kind words means a ton coming from you, Gajen. So about me, my background is, I was previously, like you said, adjunct faculty at Stanford, leading a research group in generative AI, where I also did my PhD with Andrew Ng in generative AI, and I teach about 1 million people online through Coursera and other venues in generative AI. So that is definitely my love, but my first love actually comes from product. Before my PhD, I was a product manager at Google and also an enterprise PM at a couple startups. And what I care about is giving this complex technology to end users to actually successfully use on their own. So Lamini really is this blend of these two sides of myself in a way, where it's delivering this complex technology in a package that more people in the world can use, and specifically developers at enterprises can use, not just people with top PhDs in generative AI. And I know that there are only a couple hundred of us who can deeply steer these models. And I feel like that's locking up the true magic of AI in just a few of us, essentially. So I'd like to have more people be able to develop this technology and be able to deeply steer and control this technology for the most valuable use cases, which will be the ones that are not about replacing people, because I know that's part of some of the central narrative, but it'll be about new possibilities of what we cannot accomplish today. And they will be able to develop them far better than someone like myself.
Terrific. Well, it's great. So let's get into it.
Cool.
A lot of companies, including ourselves, right, we're investing quite heavily in trying to understand this. What are you seeing in the market as you're meeting customers, especially in the context of Lamini or in general in the context of Gen AI? It's been almost 2 years now. What kind of traction, what kind of what kind of challenges and or opportunities are you sensing in the market?
Yeah, so I think at least at the enterprise level, which is who we sell to, there are a few key challenges that I think are now we can overcome them. So one of them is around hallucinations. So these models are dream machines. They actually optimize for something called generalization error, or the average error across all the examples it's seen over the internet, which makes it pretty good at everything, but then perfect at nothing. So it's pretty good at everything, which makes it capable of doing all of these different tasks and makes us think, oh wow, this thing is magical. And then it blunders on something where it needed to be perfect, for example, a revenue number, right? And it turns out us people, you and me, despite our flaws as humans, we are actually perfect at some things. We are perfect at probably recalling revenue numbers from our last quarter. So we're perfect at some things. We can remember our daughters' names, parents' names, etc. But these models won't always be that way in the way that they're trained today. And so one of the things that we focus on at Lamini is, okay, well, this seems like a very big gap to almost the most valuable use cases out there. This is a showstopper, right? So enterprises have so much specificity and in such large quantity within their organizations, whether it be not hallucinating on an earnings report or not hallucinating on intricacies and details and unique qualities of their code bases even. So being able to address that and make it so that piece of these general purpose models could be turned in, could be perfect. These things could be perfect or near perfect at some things, but still pretty good at everything else. I think that's one big thing. And then probably the second big thing is around security. I see a lot of companies grappling with this and worried that they will lose something, they'll mess up from a security angle with their data. They've spent so much time making sure that their data is governed correctly, and complies, right? And I think those are the two, for two different reasons. One is definitely compliance. The other, in different industries. The other one is around just proprietary advantage. So being able to have that as a secret sauce, as you might imagine. So being able to, these LLMs are deep derivatives of this data. They are probably the most valuable derivative of data that you can create today, because they can augment essentially all knowledge work, and they're essentially a store of data that is intelligence, you can argue. And so how do you still govern the LLM in a similar way while the infrastructure for it is such a complex beast, right? So I think that's on people's minds as well.
I get the sense that it's no longer about the quality of the model and more about the speeds and feeds. Does that say something about what's happening in the language model market?
I think what it says is we've now reached a threshold where we've unlocked a lot of valuable use cases, right? And so people are thinking, well, I believe that there are people who now believe that this technology can do something. And as a result, now that I believe it can reach a certain level of accuracy, now that I believe there's a new frontier of tasks I can use this model for, I want to optimize. I want there to be low cost. And then I also think lower latency does basically the speed of the model. That opens up new possibilities as well, right? So.
Is it the big C word of commoditization? At the frontier level starting to show up? Because in a way, it feels like there's this shift towards specialized models or smaller models that are very specific to tasks or companies or industries that are evolving quickly. Do we care as an enterprise? Do we care about who wins the frontier model race?
Probably not. Probably just care that there is a race.
Exactly. Yes.
Because then you
the
get
because we get the benefit. Exactly, right? You get the benefit of it, but how you translate it to your business is where the real differentiation comes in. And love to get your take on, because I am seeing, certainly with us as well as our customers, this shift towards better understanding of what the value is of the frontier models, but more of a focus, if you will, on specialized models.
100%, yes. And I think there is now a new frontier of what you can do with these models. So new frontier of basically high accuracy with low latency and cost. And that's very exciting, because that opens up so many different new applications. And I think I see people building that today. These models that cost billions of dollars to develop, you're asking for hundreds of billions or more. How do you drop that down, especially for an enterprise? Well, you can fine tune an existing model and turn it into what we call a mixture of experts, and do that very, very efficiently. So turn a Llama 3-like model, have it learn all these what we call memory experts, and at inference time selectively choose which experts to use and to actually put into its response. It's actually expanding the existing base model to have not external, because it is actually now connected, but connected memory, a bigger brain. And it actually it breaks this paradigm of how people have been thinking about small model versus large model, which I think is very exciting. It means you can get the intelligence of a big model while still having the latency and cost of a small model. And that's super, super exciting, I think, because then you still have those great applications at low cost, high speeds, but you also get greater capabilities and greater intelligence.
Let's talk a little bit about vertical versus horizontal use cases that you have seen, and where you see, horizontal use cases really gaining traction, sort of production-ready traction, and also vertical use cases that are starting to evolve and becoming more production-ready. One
of the exciting, what I think of as initially vertical but now pretty horizontal use cases is GitHub Copilot. So from GitHub, they have the user-based distribution through the IDE, and they have great engineers and also a close collaboration, early collaboration with OpenAI. So with someone doing Gen AI before others could do this. So they were able to create this initially very verticalized code LLM, which is not just all general purpose, just code, and just auto-completing code. And the model itself is actually really, really small to maintain very low latency, so that developers can actually get the responses very quickly. Because otherwise, if you have to wait a few
it's
seconds,
inline access
exactly.
to the,
I mean, if
right.
you have to wait a few seconds, you're already on your next thing, and you have to recompute that. So that doesn't work. And so one of the biggest challenges they had to face is something that I think it will be similar for a lot of enterprise applications, and that is this latency piece, this speed piece of the model, because that unlocks a different user experience on the either consumer or user side. So I think that's one of the premier shining, enterprise vertical LLMs. And then what else I'm seeing is in many internal use cases within an organization that are highly verticalized and proprietary. So we work with a number of enterprises. Maybe I'll actually speak into the kind of OT space. They have, let's say, like technicians that are working around the world to be able to support their internal staff of technicians with highly technical documentation, which needs to be both precise and also essentially tuned to that very technical language and information. So that is one use case that we see prevalent across multiple companies in the OT space.
We have all these amazing capabilities and products in the market, and so you can imagine sort of the excitement factor for us in thinking about how you can apply AI and Gen AI to this. So I'm going to ask you to switch roles for a second.
Okay.
Put yourself in the customer, enterprise customer, maybe an OT customer, CEO, C-suite leader. How can a CEO or a C-suite leader guide an enterprise through not just the journey, but the pace of the journey? Because it's faster than I've ever seen it. A lot of leaders, are challenged with sort of how do you guide the enterprise, but also, have the right guardrails in place, but then make the right choices, right or wrong, make the choices in a way that it gives them flexibility in how they guide the organization.
I love this. So the framework that I would apply is, first and foremost, understand kind of the security kind of boundaries of this technology and how that relates to data privacy and governance, and making sure that you don't mess up those things, right? So like make sure you understand that boundary and how these models are deep derivatives of data. That way there's no way to mess up, because the second step, what I'm telling you, is going to be around empowering your organization. And it's going to be twofold. So one is, these, I know I've been calling them shallow use cases, but horizontal use cases, essentially, it's still helpful for everyone in the organization to be able to touch this technology and get a sense for what it can and cannot do, and what can it barely maybe be able to do in its next generation, because then those are areas where you can go push. And the second piece of that is specifically the part of the organization that could be most useful is the software engineering function, because I think, again, it's not going to be experts like me with a PhD who's going to be building this stuff. It is them. There are only a couple hundred of like LLM, deep LLM experts. There are only 150,000 machine learning engineers and data scientists. There are 27 million software engineers in the world, and growing with language models helping people develop things. That is who you should be looking at and looking to be able to develop new capabilities. And I think something that is commonly overlooked is not just hiring these people, because I think people know, okay, now I'll just bring on more software engineers and invest in this. It's where do they sit in the organization? How do I structure my teams so that I can succeed in this? And it is that the software engineer needs to sit close to some of these business units who understand the most valuable use case at a business level, so that you can build very, very quickly between them. Because one of the biggest challenges of generative AI, the word generative, it means that it can create anything, but as a result, evaluating whether it's doing well is very hard. The person evaluating whether model A is better than model B, the person evaluating that, usually a business person, whoever's the end user, the closer that person sits with that software team, the better. Basically, the faster that iteration cycle will be, and the more accurate that model will go. These models are very good at optimizing, but they might not know the right objective. So if you give it the right goal, it'll go towards it. And so defining that right goal is absolutely critical. So that's why this collaboration between these teams create something that's highly effective. And so what I've seen in organizations is when these teams are embedded in those business units, or have like high way of communication between an elite, software team and those different business lines. Or use cases that I've seen explode are just the software engineer is the user, so they can evaluate on their own. Among our customers who have been the fastest to production are the ones that are embedded
in the business. Really? Okay. So shifting data.
Okay.
You touched on data. You said, right? There's been millions, billions, trillions of dollars invested in data over time.
Yes.
Right? It's always been like the key, right? Data, data, data. And we're still focused on data.
We are.
And in your journey,
yeah,
what did we do right and what did we not do right that requires us to still have this conversation about the readiness, the preparedness of data to be applied in the context of what we're trying to get done?
I actually think this is an opportunity for those who weren't always prepared and had the cleanest data to take advantage of the technology today. And the reason why I say that is because language models take an unstructured input and have unstructured output. That means, what unstructured means is it doesn't have to be as clean, right? The other thing is language models also enable us to not have to do any manual work to start seeing results from the model. These models are really good at both synthetic data generation and filtering of that data so that it can improve itself. And there's something really exciting about that. And what does that mean? That means that finding you can use these models now to automate so that you do not have to label or have offshore labeling crews to do a lot of that. And that makes it so that these companies who may not have felt like they were data ready are now able to become data ready by leveraging their software teams.
It sounds to me like there is now ways to automate getting prepared, which, to utilize the data. Are you seeing that all enterprises aware of it? Are they engaged around it?
Some are, some aren't. I would say that the more sophisticated ones have figured out a little bit around it, and the less sophisticated ones are definitely struggling to see it. I can understand the skepticism because it sounds like magic, right? It sounds very unattainable until you see it happening.
Okay. So going from there then to an area that has been very intriguing to me is agents.
Okay, yes.
And agents workflow, agentic workflow. With agent technology, I feel like we can go to an entirely another level, right? Like I can almost see sort of a pyramid of agents working, hand in hand with a pyramid of developers or process engineers, and truly over time shifting the workload more and more towards the agents. Tell me a little bit about your perspective on agentic workflows and their possibilities to impact how work gets done.
Yes. I actually think of agentic workflows, agents, as similar to object-oriented programming. So it's like a different way of viewing,
Fair enough, yes,
right?
absolutely,
It's like looking at the agent as the central piece, where it's using an LLM or multiple LLM calls internally, and it's using often tools including internal systems, so being able to interface with other systems inside of an organization, but also tools like self-reflection and like talking to, essentially thinking on its own responses, right? And even you can argue adding chain of thought in there. And so being able to do all those things that are in some ways very human, I think makes it easier for people to develop some of these pieces of technology, because LLM just feels too broad sometimes. So I feel like agent helps with, hey, this is like a person that I would know who would do all these tasks, but more, right? But maybe extending more than that. So I think that's how I think of it as a framework. And so I think it's very helpful as a framework. And then being able to extend it more practically, I think a couple different things. One is definitely making sure these agents are able to accurately use all of their tools and be able to reflect. So that's one thing. There's a lot of high precision that is involved in that. I think the second thing is, so the hallucination problem is still there. I do think that there are a couple considerations where I've seen people build out demos of agents, but they couldn't get to production. And the reasons are, and this is why it's a consideration, is because you said that pyramid of agents. There's so many agent calls in that, it's basically so many agents in that workflow that, there are 30 calls to a model, and by the time the response got there, it took minutes. It took way too long to get that actually there. And so I think, and not only that, but wrong answers were compounded. It was like in the game of telephone. So that's something to consider of, okay, you have these agents, they're incredible. How do you make sure that they are accurately passing information off? And how do you think about reducing the chain in different ways? You still have it, but think about how you want them to interact, maybe even at a higher level, to have that, maintain that low latency still. That's necessary for production.
And on the topic of cost of operations, or TCO.
Yes.
Right. What are you seeing? Because one of my biggest concerns with all of this is ultimately, the haves can invest tremendously, right? But then there are enterprises of varying scale that can't invest at the same level. And so one of the concerns I have is that at one point does total cost of ownership become a challenge?
Last year, barely part of the conversation. This year, definitely a much heavier part of the conversation, where people are thinking, for most of these applications, I actually can't sustain that, in really high inference costs, for example, from a large model. So how do I think about use case versus cost and ROI. And I think something that is exciting to me is that you can actually start small. I'll see ROI from the model and then expand it. Start from a smaller model sooner. And instead of saying, let's go with this huge model, and let's try to make it smaller, that's actually a hard distillation problem where you can't maintain whether it be guardrails or accuracy of the model, but start small and actually improve it. I've seen that succeed.
So is it sort of and correct me on this, is it more of a federated approach for a company like us, like a conglomerate which has multiple businesses? Should each business could start with a smaller model and then we could aggregate from there to, like in this space, right? There is no historical evidence of what's the right thing to do, right? So we kind of go down a path and then you hope that you pick the right path or quickly pivot away from it. How does a leader think about what's next?
So I think it's about, now there actually has been enough to take stock of what the trends are and what is backing those trends. One is that these foundation models are going to have increasing capabilities. I think that one is true. By the way, last year, it didn't even, there's even uncertainty around open source being able to catch up. That clearly has caught up, and I think given the competitive pressures that will continue as well in concert. So those are a couple trends on the LLM side. Another trend on the compute side, the demand for compute won't necessarily lessen by as much, especially as more use cases are developed and better use cases, more valuable use cases are developed and people get their hands on even more of this technology. So I think these are a few underlying trends, and I'm sure there are others that have stayed the test of time, where time is, I realize, only a year or two. And then I think other ones that I'm seeing that have a seed from decades ago that people don't quite realize. So one here is, and this is actually what memory tuning is based on. I didn't actually call it out, but it is a merging of two very, very large fields. One is AI, and the other one is information retrieval. When two fields with multiple decades of research expertise for their specific areas collide, the amount of innovation is incredible. And it's also hard to predict, but it's incredible, and there will be big advancements there. Another intersection is at the hardware and software layer for compute, that'll be big advancement. And we already saw that with transformers. The whole point of transformers wasn't that it modeled the human brain, it was that it took advantage of compute efficiently. How do you take advantage of compute today for workloads today, but also workloads tomorrow? What are they gonna look like? How do I support them? How do I organize my organization around them? How to get there most efficiently? And then how do I enable as many people as possible so that we can discover what those even are?
I used to think of sort of, is there a way, sort of this notion of being ambidextrous, right? Trying to do two things, if you will, at the same time. But then I kind of shifted away from that. I said, okay, maybe it's 2 speed, right? Now I'm sort of on 3, like, what is, because it's sort of like, there's what you can get done now.
Yeah.
There's what you can maybe plan for within a 18-month horizon. And then the third one is it's just a North Star, right?
Yeah.
You know where you want to go, but everything else is fluid.
Yes.
Right, and you have to just adjust on the fly and use 1 and 2 to adjust.
Right.
Everybody has some form of approach, but ultimately it needs to be applicable to us, and we need to try to stay. I don't think we need to be bleeding edge, but certainly leading edge. But doing that in this environment is challenging for anyone. So Sharon, thank you. I feel like I went to a course or few courses at Stanford, spoke to a founder, spoke to an entrepreneur, somebody that's advising government. I feel like I got all of that in this very short window of time, and it truly has been thrilling and a fantastic learning experience as well. So thank you for making the time to be here with us, and look forward to being in touch and learning more as things evolve.
Absolutely, and thank you so much for having me.